Now that we've seen how the N-terminus reacts as a nucleophile in tagging reactions, we can come full circle and examine how to sequence a polypeptide one N-terminus at a time. What we need to do this is a reagent that is electrophilic enough to react with the nucleophilic amino group on the N-terminus, but also able to cleave the peptide bond via addition-elimination after forming a bond to the N-terminal nitrogen. Remember that if we simply treat the peptide with a reagent that cleaves peptide bonds, we won't selectively cleave the peptide bond on one end or the other of the polypeptide chain, and we won't be able to isolate different positions within the amino acid sequence. We need a reagent that selectively operates on either the N or C terminus. For the sequencing method known as the Edmond degradation, the compound phenyl isothiocyanate serves this role. The central carbon atom, much like the central carbon of carbon dioxide, is a good electrophile and can be attacked by the amino nitrogen atom. Since the N-terminus is the only nitrogen atom that is not part of an amide, addition takes place selectively at the N-terminus. An internal proton transfer then generates a neutral intermediate called a thiocarbamate. So far, this mechanism should look conceptually similar to the tagging reactions we saw in the last webcast. Where things get interesting is in the next step, when hydrofluoric acid is combined with the thiocarbamate. Protonation of the carbonyl oxygen occurs, making it more electrophilic, and the nucleophilic sulfur atom in the thiocarbamate portion of the molecule attacks the carbonyl carbon in an ADN or nucleophilic addition to a polarized pi bond elementary step. Here, the formation of a 5-membered ring helps encourage this process. General acid-assisted beta elimination then follows, with the hydrofluoric acid assisting in the dissociation of nitrogen from the 5-membered ring. After some additional proton transfers, a thiazolene ring containing all the atoms of the N-terminal amino acid results. The remainder of the peptide chain is left untouched, and the thiazolene can easily be separated and characterized on its own. With the first thiazolene ring separated from the remainder of the polypeptide, a new N-terminus remains. We can then repeat the process at the new N-terminus, which is on the second residue in the peptide. By repeating this process until no amino acids remain, we can iteratively determine a peptide sequence. In this webcast, we learned how to determine the sequence of a polypeptide through repetitive, selective cleavage of the N-terminal peptide bond. In the next webcast, we'll explore the problem of synthesizing a peptide of defined and known sequence. We'll see that issues of selectivity are important for this problem, but by harnessing the inherent reactivity of the amino and carbonyl groups in the amino acids, we can string amino acids together to create peptides with well-defined structure.